All right, so hi everyone, I'm David. I'm a senior solution architect at Couchbase. I'm going to actually go back to the microphone now. I'd like to talk to you a little bit about Couchbase, and since this is a big data conference, I'm going to be talking about not Couchbase the database, because presumably all of you know what it is. I'm going to be talking about how to use Couchbase in the context of a big data system, a large distributed system, and how it's actually very convenient to use Couchbase as a central hub for various big data architectures. Right? So we're going to start with a very simple question. Why would we even use Couchbase in a big data system? It's a database. It's not Hadoop. It's not Spark. It's none of those things. And why in particular Couchbase and not any of the many competitors? So several reasons. First of all, I work for Couchbase, so that's why the talk is about Couchbase. But more importantly, Couchbase is a very fast NoSQL database, and it's optimized for specific things which are very valuable for certain big data tasks. Specifically, very high throughput for writes and reads, and very low latency for individual writes and reads. And with that, we can actually use this ability to augment many processes which other distributed systems use. So for most of you, I think this diagram is going to be very familiar. You've been here all day. I'm sure you've heard the words Lambda architecture at least 20 times, right? Has anyone not heard about Lambda architecture? Raise your hand, like one guy say, I haven't heard it. All right, so Lambda architecture, for those who don't know, is a very new fancy buzzword for a very old and existing concept, which essentially talks about when processing live data, you can do some things immediately, and you have to do some things afterwards because in the moment you don't have enough data to do it. For example, pretend you have a stream of events coming from sensors, or you're an advertising company and you have a stream of clicks, user interactions with your advertisements, or you're doing fraud detection and your events are actually credit card transactions which you need to validate. So all this data is coming to you live all the time, and normally you want to do something right away with each item that your system gets. And it doesn't matter how you get the data, whether it's a website user interaction or mobile devices sending you events, all that, or sensors. The important part is you get data very fast, and a lot of it, and you want to do something with it immediately. On the other hand, and that's the real-time part, you want to do something like show statistics, show how many events you got. If it's credit card fraud, you want to be able to immediately say, is this transaction a fraud? Because there's a guy standing with his credit card in his hand, waiting for the payment to go through. And all of those things are close enough to real time to be called real time. Now, at the same time, there's usually things you want to do which require a bulk of data. For example, you want to create fraud profiles, right? How can you tell a transaction is a fraud? You need to go collect enough data to run some kind of offline process and create the profile of what a fraud transaction looks like versus what a real transaction looks like. Or if you're serving advertisements, you want to collect enough data on users to be able to predict what kind of ads to show to which users. And those are processes that you cannot actually do in real time. You have to create a bulk of data and do some kind of processing. And I'm sure everyone has a reasonable idea in their heads how they would, hopefully everyone has a good idea of how they would build a system like that. There are many different ways. There are at least 20 different products for each part of the system. But normally for the real-time part, you would see things like using Storm to process event, or Esper, or some kind of queue system which accepts events like Kafka or Kinesis on Amazon. And you do a lot of this stuff with events in Storm or in Akka, process them, and then you send those events to some kind of database. And for the offline part, I'm sure everyone who isn't thinking of Hadoop right now for the offline part? Who isn't thinking? There you go. No one is missing there. All right. Who actually thought about Hadoop? And who's asleep? Everyone. All right. So obviously, Hadoop is the straightforward thing to do here, but there's other processing systems. There's Spark, obviously, which is coming in very nicely to replace Hadoop, and a bunch of others. And generally, you have these two parallel streams of data, one being processed in real time, one being processed in offline. And most of the time, both of those processes require some kind of very fast data store, both to buffer the incoming data and to store the results, because eventually you want to be able to use this stuff you create to, for example, serve it to users, or show ads, or store your user profile somewhere. And Couchbase, which brings me to Couchbase, as I said, has certain features which are very convenient for this particular use case. So specifically, it's very fast, has a caching layer, it's a document database. How many people actually know about Couchbase and what it does? It's like 3, 4, about 20 people out of like 50. That's good, that's actually good. So for those who don't actually, who aren't familiar with Couchbase, Couchbase is a distributed NoSQL database. It comes with a very large built-in caching layer, which provides very high read performance, very low latency for reads. And it also has a write-through cache, so it has very low latency and high throughput for writes. And it operates with keys and values, with the values being in JSON format, which is pretty much the de facto standard for data exchange for databases now. So it's very convenient to store individual items of data as a single object in Couchbase. So for example, when all this data is coming in, and you have users interacting with your website, and you want to record clicks on advertisements, or you have sensors sending in data, or mobile devices sending in data, you need somewhere to put this data. Now, one of the things you can do is obviously put it all in a big queue. For example, put it all in Kafka or in Kinesis on Amazon, and then someone will eventually read the queue and do something useful with it. The problem with that is anything you put in a queue isn't immediately available, right? It's not immediately useful, and also you cannot get the latest item without reading everything before it. Now, sometimes queues are exactly what you want, in which case, wonderful, use Kafka or use whatever queue you want to do. But other times, what you want to do is you want to persist your data as soon as possible so it doesn't get lost. And you want to do it in a useful format so that other people can, or other systems can interact with it right away without having to read all the data before it, or to be able to change this data, because queues are, by definition, immutable streams of data. Each item is exactly as it was when it was written in the queue, it doesn't change. Databases, on the other hand, are by definition mutable, so if you push all of your data into a database first, it's actually, some use cases are very convenient. For example, building a user profile, right? So if you have users interacting with your app and you want to record their behavior, you keep adding to the same document and not storing new documents for each interaction. Now, on the other side of that, besides just pushing data in and out of Couchbase, Couchbase also provides two mechanisms for getting data out of it in a convenient stream-like fashion. First of all is the replication mechanism. Couchbase has a cross-data center replication mechanism, which can also be used to actually feed data from Couchbase to other systems. And second, the actual API Couchbase uses internally for replicating data, called TCP, or Data Exchange Protocol, is actually publicly available, so anyone with the Couchbase driver can connect to that API and participate in the database replication. So every time something changes in the database, your code also gets the change. And combining those two means that any change that happens in the database can also be injected into your streaming system. So that brings me to my first demo, which is we're going to spin up a very small Storm cluster, and we're going to use, Spark cluster. We're going to use Spark streaming to bring a stream of tweets in live from the internet. We're going to push all those tweets into Couchbase. We're going to do some pre-processing on the way, and once we push all the stuff in Couchbase, then we can do something useful with it, right? And the reason we're pushing it into Couchbase is because it's a very high volume, presumably, not on my laptop obviously, but in real life it will be a very high volume stream, and you need to store it somewhere fast, and then you want to take it out from the database and do something else with it. So let's take a look at how that will actually work. How many people can actually read Java and aren't afraid of it? It's like one person admits, yes, I write Java. All right. So this is my, can you actually see that? Yes, excellent. Yeah, there we go.
Excuse me, can you make this available?
More? That's about as big as it's gonna get, I think, folks. All right. Are we good? It's close enough. Java, Scala, whatever. No, all right. Fair enough. I'll take the correction. It's Scala. It's much better than Java, of course, because they stole all the good ideas from .NET. All right. More to the point of Couchbase and Spark, right? We have two Spark streaming streams which connect to Twitter. I'm not going to go into how you do that. Go read the tutorials. But essentially, we bring a bunch of tweets in. I give some filter keywords. Now, I started out with trying to get all the tweets with keywords like Couchbase and NoSQL and Kafka, and discovered there aren't any tweets like that. Nobody tweets about Couchbase and NoSQL, so it's not a good demo. And keep that in mind because you need to tweet more. So I went with something that's obviously going to generate a lot more tweets, which is keywords USA, Iran, and Russia, which gives a nice volume of tweets. So what we do here is we get the stream twice. First time we get all the items all the tweets and create 5-second windows and calculate the most frequent hashtags every 5 seconds. Once we have that, it's a small item of data. We push that into Couchbase, and it's a nice pre-processed piece of data which we can actually use directly. So, for example, we can go to a website and show you what the most popular hashtag is in the last 5 seconds, because we already have this data. Spark generated it for us, and it's sitting in Couchbase, so it's very fast and efficient to get it. The second thing we do is we just take all the tweets exactly as they are, wash them a little bit, so throw out a bunch of data we don't need, leave just the 3 fields we want, which is the username, the date, and the text of the tweet, and the location, sorry. And we push that into a different bucket in Couchbase, a different database in Couchbase, and that's our raw data, which we're going to do something with later with a different demo. Right. So this is actually already running. As you can see, we've got tweets incoming. It's very simple to do, and in order to save it in Couchbase, all I had to do was just include the Couchbase library and add to my Scala definition, save to Couchbase, and tell it where to put it. So this one's going to a database called default, and that one's going to a database called tweets. And that's all we do. So if you go to the Couchbase UI, which is kind of small, but hopefully you can see it anyway. Look at this. We actually have a bucket, and yes, indeed, we have 10,000 tweets so far while I was talking, and it keeps going up. All right, that's very useful. We can actually now go and do something with that. Now, what would we actually do with this? Go back to this. There's a second part of the demo in just 2 minutes, so be patient. Now we can actually, since we have our data in Couchbase, we can first of all, we can query it, right? We have the tweets aggregated already every 5 seconds. We can go and build some kind of dashboard and show the tweets, or we can go and do whatever. And if we talk about a real world example, we can connect to an actual stream of data like advertising clicks and calculate something in real time, like how many users are clicking which ads, maybe show statistics, maybe do something useful with that. And if we're talking about actually taking this data out and using it, that's going to be in the second demo. We can actually now connect some kind of real-time system to Couchbase to extract this data. So that brings me to the second part of it, which is we have all this data streaming into Couchbase. How do we stream it out, right? We don't want to have to maintain a second system. I don't want to also install Kafka and maintain Kafka to get my streaming parts and install some other system to get whatever. But for example, I want to take all this data and take every change and one thing, store it in HDFS, so I can do Hadoop stuff on it later. And I want to, let's say, print some summaries of it. And I want, for every event, I want to enrich it. I want to take the event, take the tweet, and add some more data. For example, I can look up the address of the user offline and add it to the actual item and save it back to Couchbase, right? Enrich the data afterwards. So for this, we need to be able to, first of all, connect to the actual live stream of data coming in. Every change triggers an event in our code. And then maybe we'll add some extra nifty features, like we want to show a graph of all the users on the map, right? If they have locations, we want to show them on the map. So we'll also connect this thing to Elasticsearch, so we can search the tweet text and show nice graphs in Kibana, right? So this is what we're going to do. We're using the streaming protocol for DCP, for data change protocol, which is part of the Couchbase Java SDK, so anyone can just take the SDK, and in addition to using all the basic database stuff, like putting data in and out, they can also open the stream and get this, a continuous stream of all the changes from the database, and then do something with that. So I took that and I wrapped it in a bolt for, in a spout for Storm. How many people have actually heard of Storm, at least? Everybody, excellent. Do you know what the difference between bolts and spout is? Doesn't matter. Spouts basically are the input of the data, and bolts process the data afterwards. So what we want to do is we want to create a spout which connects to Couchbase and pulls out all the data, and then pushes it on to different bolts. So we'll have a bolt which writes to HDFS. We'll have a bolt which just prints some debug stuff on my screen, and we have a different bolt which filters events and only lets some of them through. And you can imagine that with Storm you can build pretty much any kind of bolt. So if you want, for example, to interact with the object in Couchbase, you can use the same SDK that is in the stream to go and write back to Couchbase. So you can do a full cycle around in Storm. All right, so let's take a look at Storm, which unfortunately is actually Java and not Scala. I'll zoom in. And again, I'm not going to go into the code too much. So, but what all we do is we create one bolt for HDFS. I have Hadoop running the VM on the same laptop. And we're going to be writing all the data we get from Couchbase. So every change for every document, we'll write it to HDFS. And we have another bolt, which all it does is just print stuff to screen. So for every document, it prints a dot. And every 1,000 documents, it prints, like ends the line. And we also have a filter bolt, which stands before those and filters out all the events that we don't want. For example, we want only events of creating new documents, and you don't want to know about deleting documents. So we filter those out. And from this, you can imagine that you can create a whole logical flow of what you want to do with your streaming data, and even do loops within the data and so on. Now all I have to do, by the way, I still have Spark running in the background, so we keep bringing more tweets. So if I run this part, this will now connect to Couchbase, pull the data out, and once Spark actually spins up, we'll actually see the printer bolt printing stuff on the screen. There we go. So for every new tweet that comes in, we print some more stuff. And I've tested this. It can actually keep up with much higher volumes of data. Right? On my laptop, I managed to get about 30,000 events per second. And obviously on the production cluster, it's going to be orders of magnitude more. But in addition to this, we're also writing to HDFS. So if we go to my Hue console, which was here, and I'm going to make it larger so you can actually see it. For those who aren't familiar with Hue and Hadoop, well, I'm sorry, go read on the internet, because I only have 25 minutes. But essentially, Hue is a tool that comes with the Hortonworks data platform, and it includes stuff like very basic file browser for HDFS. As you can see, we're also writing stuff to a folder called Couchbase. If we go here in the file browser to the folder Couchbase, you can see that yes, we have a text file which keeps growing all the time. This one. And this actually includes every tweet we get. So it's a log of all the items that ever changed in Couchbase. For example, if we change the document, we'll have duplicates of that document with all the changes, an entire log of everything that ever happened to it. So if we want a full audit log of everything that happened to our data, there we go, it's all sitting in HDFS. I can reconstruct timelines. So if, for example, if I'm recording a visitor traversing through my website, and every event actually changes a document, I can reconstruct the entire log of what the user did with the website by going to HDFS and seeing the order of the documents which got recorded. Right? And if I want to reconstruct the data, or if I want to only keep a partial data set in Couchbase, because it's more expensive, and to store a bunch of data in memory, and I want to keep my full petabyte of data in HDFS, I can do that. And last but not least, because we have 3 minutes remaining, and I'm going to be on time, thank you. Last thing we want to do is do something nifty and useful with this data. We want to show some graphs, because everybody likes graphs. We want at least one pie chart and one map. So for that, we're going to do a integration with Elasticsearch, because Couchbase also comes with a plugin for pretty much everything in the world, but among those things, there's a plugin for replicating data to Elasticsearch. And Elasticsearch has the most awesome plugin ever called Kibana, which shows you graphs and dashboards which you can do create very easily on the fly. So what we're going to do is, I've already configured replication from Couchbase on my laptop to Elasticsearch. And for those of you who aren't familiar with Elastic, again, only 25 minutes, sorry, I can't teach you about Elastic, but please read on the internet, it's awesome. So all it does is take every tweet from the tweet bucket in Couchbase and basically just replicates it to Elasticsearch, which indexes it. It does full text indexing on the English language. It does indexing on the coordinates in the tweet and all that. And then we can go to Kibana and create an interactive dashboard which shows various statistics. You can actually see it on what we have. So for example, we can show all the tweets on the map. So the bigger the dot, the more tweets from that region. We can show a distribution of the most popular tags, which, by the way, this little column comes from the pre-generated stuff I did in Spark earlier, right? We're counting what's the most popular hashtag every 5 seconds. So this is the data that fits this box, right? It shows the 5 most popular hashtags for the last 5 seconds, right? And on the bottom here, we have a timeline of how many of each word we've seen in the last minute. And there's a bunch of stuff you can do, and it's very easy because Kibana lets you actually create dashboards and visualization like this on the fly. And also, it's actually indexed in Elasticsearch. So if I want to search tweets, right, I can actually just do that. I can do something like doc user something. Okay, we don't have any of those. Oh, we do. We have one user. Or I can do full text search, find me the word shoes in all the tweets, and it will find me all the tweets with the word shoe in them, and show me on the map where the shoe person tweeted from. All right. So just to summarize this whole thing, so I went through a bunch of topics very quickly. The reason being, I took 4 topics, each one of about 1 hour of talks, and I combined them into 20 minutes. But my point in this whole thing was that there are some use cases where you do large distributed system processing on live data as well as offline data that can actually benefit from having a very fast database in the middle serving as the primary ingestion point, because the benefits you get from that are immediate persistence. You don't need to build an extra system to maintain to actually persist it somewhere else. If you want your data to go into the database first, you know it's going to stay there. It has integration with pretty much every big data system that's popular today, from Storm, Spark, and Hadoop and Elasticsearch and so on. And it's very easy to create logic which feeds back into the data to enrich the data in real time asynchronously. I think I'm actually under my time. No? I'm exactly on time? Okay, so thank you very much. Hope you enjoyed it. Are on GitHub if you want to play with the code.